Okay. So first we'll try to look into data flow characteristics. Like we will see reliability, we will see delay, jitter, and bandwidth. What are these parameters? Then we will look on to the things like how we can improve quality of service. Okay. So as you can see in this slide, data flow characteristics are uh, reliability. Okay, how a particular application is bound towards these parameters like reliability, delay, jitter, bandwidth. Okay, when I say FTP, which is important for that. When I say audio application, which is important. Okay, so like that we will be discussing with respect to data flow characteristics. The first parameter is reliability. So when I say reliability, it's something like whatever the data we are trying to send, that has to be delivered at the other side in order without any errors. Okay, that is what we say reliability, right? If source is trying to send some information, that has to be delivered in the same order, okay, and also without any errors. Okay, so lack of reliability, we can say like losing of a packet or losing of an acknowledgement. In any of these cases, there can be retransmission, right? For example, if you lose a packet, lose a segment or packet, or let us say you have been uh, communicating from client to server, and a client has transmitted a data and server has acknowledged for that, but in the middle acknowledgement. Okay, so that is nothing but lack of reliability. Achieving reliability means without any error, we are able to provide the service of delivering in ordered packets without any error. Okay, and when I consider sensitivity of different applications to reliability, it is not going to be same. Okay, for example, if I consider with respect to a mail or file transfer protocol, we need to have more reliability. The reason is, if I lose a mail, that means somebody has transmitted a mail, destination has not received that. There is no way I can correct that except from retransmission. Okay, so I expect to have some reliability. File transfer protocol also same. Same thing I am repeating, like audio conferencing or video conferencing we are talking about. If I lose some of the information also, I'll be able to extract the information. Extract in the sense without any issue, we will be able to continue the communication, right? You are able to understand the difference. When I talk about electronic mail or file transfer protocol and the case of audio conferencing, both are not same. I expect to have reliability, complete reliability with respect to email and FTP, but I don't need that kind of reliability with respect to audio conferencing. And moreover, if I have reliability with respect to audio conferencing, that is the issue I am going to have. Okay, because I say something, whatever I am speaking now, let us say there was some issue, okay, because of which we had to retransmit. What happens? I say some sentence, a particular word of this sentence is retransmitted in the next sentence. It won't be appropriate, right? So that's why we say for audio conferencing or telephony applications, we don't expect to have reliability. Okay. Is it clear about reliability, how it varies with respect to different applications?
Yes, sir.
Uh, I could not hear properly.
Clear, sir.
Okay. Next parameter we have is delay. Okay. So delay is nothing but, for example, source has transmitted it, let us say 10 seconds. Okay. Receiver is getting the information at 11 seconds. Okay. The time difference, whatever we have, that is considered to be delay. Okay. Let us say we are transmitting a file again, like with each and every application, the sensitivity to delay varies, right? So when I consider file transfer protocol or email, let us say whether 1 millisecond delay or 2 millisecond delay, 3 millisecond delay, I don't bother, because if I get an email, it will be delivered completely. I won't have like one sentence of email will be delivered now, and after 1 minute I'm going to deliver another sentence of email, right? So I'm not going to have much variation with respect to quality of service when I talk about either file transfer protocol or email. But let us say I'm talking now, okay? I say something, after a minute you hear that one. That delay is not acceptable, okay? So especially when we had a 3G network, and if you are trying to make WhatsApp calls, how it used to be. Now WhatsApp has improved a lot, but if we were having teleconference or normal voice calls through WhatsApp, we used to have a lot of delay. I ask something now, after some 10 to 15 seconds, after that you'll be hearing that, okay? In between that there will be a pause. Sometimes we feel like the other person could not hear, and we will be talking again, okay? These kind of experiences even you may have seen with respect to WhatsApp calling, right? Yes or no?
Yes, sir.
So when I consider audio conferencing or any application related to telephony, delay is very, very sensitive. But with respect to file transfer protocol or email, they're very, very, like you can say, like they are not considered much important. Okay. Next we have jitter. Even we talked about jitter in our lab sessions also. Jitter is nothing but variation in delay. Okay, so to understand that, maybe I can draw a diagram here. Okay, basically timeline diagrams as usual. Let us say, okay, these points you consider like time units: 10 seconds, 11 seconds, 12, 13. Okay, like that you consider. Here also I have like that. Okay, they are not straight, but just bear it, consider that that straight lines. Okay, what happens in this case is, for example, if I have constant delay, we said like jitter is nothing but variation in delay, right? If I have constant delay, what happens is, I send here, let us say 1 unit of time we are going to have delay. I'll be getting here first packet, second packet also I'll be getting here, third packet I'll get here. Okay, exact point. Fourth, fifth packet. Okay. In case this is something related to a movie, let us say, okay, I have constant delay of receiving the data. So what I can do is, in this particular case, I can just wait 1 second or 2 seconds. Let us say I start my communication at 10, start transmission at 10 seconds, let us say. In that case, what receiver can do is try to stop playing till 12 seconds. Okay. Uh, it means like I am starting at this particular, instead of starting at this particular 11 second, I am starting at 12 second. Okay, what happens when I try to start at 12 second, already I have in buffer two packets. Okay, when I reach 13 seconds, I have again buffer like two packets are available, 14 two packets, 15 two packets. Always I have something in my buffer which I can play it. Okay, but let us see the other case wherein I'm not going to have constant delay, but first one, as it is coming. Okay, second one also, as it is coming. Third one, let us say it is having 2 seconds delay. Fourth one, let us say it is going to have some 5 seconds delay. Okay. Let us try to follow the same approach which we have done previously. Try to start at 12 seconds. Okay. When I start at 12 seconds, basically here I have two packets available. 13, only one packet is available. 14, only one packet is available. When I reach 15 or 16, I don't have any packet to play. Okay. Are you able to understand what I am trying to say?
Yes, sir.
Okay, so this we used to see, especially in the case of 3G when you are trying to play YouTube. Okay, in YouTube now also you can see when you are playing, beside that red color, whatever we see, you will be having some gray color which will be moving forward, right? That is the buffered data. Okay, so in case if I have buffered data, there is no issue. But if I don't have buffer data, what happens? We used to see like there used to be circled dots in which it will be moving, buffering basically, right? So that buffering will be there whenever we have variation with respect to zitter. Okay, in that case, we will have to consider like what is the worst value of delay I can have. Let us say 10 seconds. Okay, start from playing till 15 seconds. Okay, I received the first packet. Wait till 15 seconds. After that, you start so that you won't face any buffering issues. That's what we used to do even in the case of YouTube, right? Pause for loading the complete video. Then we used to start playing that so that we feel like continuity is there. Okay, so we did like that or not? Have you done like that in YouTube? Or always you had excellent connectivity and you didn't have any buffering?
We had, sir.
Yeah, so like that is the issue with respect to zitter. Okay, basically it is nothing but variation in delay, and this is very very important with respect to audio and video applications. Even many a times with respect to WhatsApp video calling we are facing today also. Whenever the signal is not proper, it keeps on saying like connecting, or you won't hear anything, complete silence will be there. Okay, then the last parameter or last characteristic is bandwidth. Different applications basically they require different bandwidths. If I consider video conferencing, then obviously we require a lot of bandwidth. But if I take the case of just email, we will be requiring very less bandwidth. Okay, so that is about data flow characteristics. Then we try to look with respect to some flow control mechanisms um, to handle quality of service. Okay, so we discuss traffic shaping or policing, or we also look with respect to scheduling. Okay, there are different mechanisms how we can do flow control to improve quality of service. One is traffic shaping or policing, where we talk about the important topic I was talking about, leaky bucket and token bucket. Scheduling, that's nothing but traffic shaping. Okay, FIFO, priority queuing, and weighted fair queuing. We discussed in lab also. We did experiment also. Then resource reservation and admission control, where we have integrated and differentiated services. Okay. Okay. I don't want to talk about integrated and differentiated service as of now. Uh, this characteristics is done. We discussed these things. Okay. See, like when I consider different applications, how we have the sensitivity. When I consider FTP, as we said, reliability is very very critical. But I don't consider delay and jitter as very important things. But I need bandwidth. Okay, it's not very sensitive, but at least medium bandwidth I need to have, because let us say I'm trying to send a file of 10 megabyte and I have just 1 kilobyte speed coming. Okay, I need to wait at least 1024 seconds to be able to receive. Okay, so at least medium bandwidth we should be able to provide for FTP. Okay, then when we go with HTTP, reliability is critical. Okay, and delay also little bit important, because hypertext transfer protocol we say, right? There we might be talking about images, we might be talking about video, audio, all those things, the web pages which we talk about. Okay, so delay requirements are not critical, but medium requirement is there. Okay, whenever you are loading a web page, okay, if it has video content and all those things, we won't be anyway interacting directly with the images or video, so delay requirements are little bit less. Okay, then bandwidth also we require medium bandwidth. Audio on demand, we don't require reliability at all, because if you provide reliability itself, we are going to have issue. Okay, then delay, audio on demand, we don't have any issue. Okay, so you need to understand, audio on demand, video on demand, we are saying delay is not critical. Okay, that's something like I have a music file. Okay, let us say a music file is there, mp3 file in internet, and I want to download. I don't want to bother about delay in that case, because once you completely download, you will be playing that one, right? So I don't have any issue with respect to delay. But when I consider voice over IP and video over IP, then we are going to have criticalness with respect to delay. That means video conferencing or teleconferencing. Okay, real time applications, delay is very critical, and in all the cases jitter is also very critical. And you can see with respect to bandwidth requirement, audio we are going to have medium requirement, video high. Okay, like that we are going to have sensitivity of different applications. Then we have flow classes. Okay, so what are these flow classes? We have seen CBR, VBR, all those things, right? Okay, so the same thing we are talking about here. CBR, constant bit rate, then variable bit rate, non-real time, and variable bit rate, real time. So constant bit rate already we have seen. Variable bit rate, non-real time means basically users in this class send traffic at a rate that varies with respect to time, depending on availability of user information. Okay, so you can consider something like multimedia email, sending a multimedia information through email. Variable bitrate real time means this is something like you can consider interactive compressed video. Okay, which will be uh, like critical with respect to delay variation. Okay, if I have interactiveness in whatever the application we are considering, that is real time, and if I don't have interaction, then it is considered to be non-real time. Okay, and then we have something called as available bitrate. This is especially used in ATM services. Okay, where we go with rate based flow control. Then unspecified bitrate also we have, especially with respect to TCP IP, we are going to have these things. Okay, we won't have any specific requirement which are told before. Okay, then let us see flow control mechanisms to improve quality of service. Okay, so first thing we will be looking at is scheduling. Okay, so mostly at router, whenever we have multiple packets are coming, then it can be delayed. Okay, and it may also experience jitter, and may also be discarded. Okay, and it may be assigned with some bandwidth. Okay, so we see at routers different scheduling techniques which can improve quality of service. Okay, so first we will look into FIFO. As you can see here, whenever we talk with respect to a router, we are going to have input and output queues. That's what we have seen, right? Whenever the queue is full, obviously we need to discard the packet. We won't be able to store them. Okay, so when there is some space, we are going to enqueue the packets. Okay, that means we are just adding the packets in this particular thing. Okay, So let us see this timeline diagram to understand what is happening with respect to this FIFO. As you all know, FIFO means first in, first out. Okay. So first one has arrived at T1, second one has arrived at T2, third one has arrived at T4. But we have some requirements here. Packet 1 requires 3 time units to process. Packet 2 also requires 3 time units. Packet 3 requires 2 time units. So when I look with respect to T1, first packet will be processed from T1 to T2, T2 to 3 and till T4. Okay, till T4 you will be processing. Okay, so this one represents arrival of a particular packet and this one represents when that particular packet is departing. Okay, then second packet also it is taking 3 time units. Okay, and it is departing at T7. Third packet is it is taking 2 time units and it is departing at T9. Okay, so when you look with respect to that, you should be able to understand, like basically we are trying to give as per like how they have entered in this particular thing. Okay, so when we consider with FIFO queuing, all packets are treated same in packet switched network. Okay, so whether you have file transfer protocol or voice over IP or email or interactive teleconference, anything we are going to treat in the same way. If we need to provide different services to different classes, then we don't have any mechanism in FIFO. Okay, so when then we are trying to look with respect to priority queuing. Okay, in priority queuing we are going to have queues. Again we are going to have queues itself, but we are going to have queues with respect to priority here. Okay, so what happens here is, like some of the cases wherein they are very sensitive with respect to delay and all, then we are going to give it for high priority. Okay, then the remaining things we are going to keep within low priority queues. So what happens in this one is, basically I am getting packets here. I have a classifier to differentiate whether it is high priority or low priority, like that. Okay, in case if it is high priority, I'll be checking the queue. If it is full, I am going to discard. In case if it is not full, I am going to enqueue in high priority queue. In case the traffic requirement, basically where we talk about this priority with respect to type of service, we said, right, what is the type we want to have, what is critical to me, whether it is throughput or delay, bandwidth, what is critical to you, we are going to talk. Okay, so depending on that, if it is low priority, we will be keeping in low priority queuing. So what happens in this one is, okay, so see here, uh, we have a packet which is coming here, uh, let us say at T1, okay, with high priority, and at T2 I have a low priority one coming. Next at T3 I have high priority one coming again. Okay, T5 again I have low priority one. T7 again I have high priority one which is coming into picture. Okay, so let us say the one which we are getting, the first packet, if it requires 3 time units to process. Okay, we are saying the first packet requires 3 time units to be processed. So I will take from T1 to T4. Okay, when I look with respect to T4, I have second packet which is there in highest priority queue. Okay, and uh, a packet, like first packet in low priority queue. What happens in priority queuing is, I am going to give priority to highest priority queue. Okay, so you need to understand, even though the low priority, we have this low priority queuing one, right? The first packet in the queue of low priority one. Okay, this one, even though it has arrived before second packet of highest priority in highest priority queue, I am not giving access to low priority queue. Okay, I'll give access to second packet of highest priority queue. Okay, so till to T6 I'll be handling that. Okay, When I consider T6, I don't have anything in highest priority queue, but I have two packets waiting in low priority queue. Now I will transmit this low priority queue, which is also asking us to provide 3 time units. Okay. Then at T9, if I see, I had one highest priority packet, one lowest priority packet. But lowest priority packet has arrived first compared to highest priority queue. But we are giving access to highest priority one itself. So indirectly what we are trying to say here is when we consider priority queuing, we are going to look with respect to highest priority queue. Whenever that queue is empty, then only we are shifting to lowest priority queue. Okay, let us say continuously I have some interactive video session which is going on and somebody is trying to send emails in middle. Okay, so always I am going to have highest priority queue filled. So there is no way in which I will be able to send emails when we consider priority queuing. Okay, so that is the issue we are going to have in priority queuing. To handle that, what we are doing is we are going with weighted fair queuing. Okay, so in weighted fair queuing, we are going to assign some weightage. Okay, for each application. Okay, so in this techniques, basically packets are again we are doing like classifying. Okay, class one, priority class two, class three, like that. Okay, but each and every queue, as I said, we are attaching with a weight. Okay, higher priority means we are going to give high weight, and lower priority means we are going to give low weight. And system how it process in each queue is we are going to give round robin fashion. Okay, so you can consider like for example the complete throughput of router is R, then we will be doing like highest priority queuing, we will be giving R by 2 throughput. Okay, that means let us say I have some 60 Mbps or 60 megabytes bandwidth I have. Okay, so for highest priority queuing I am going to give 30 units. Okay, 30 megabytes. And second case, okay, let me write here, total throughput is, let us say R equals to 60 Mbps I have. Okay, and we are saying like if I assign 3 to 1 as weight, okay, we will just divide these things, 3 by 2 we will be considering. Here we will be considering, sorry, R by 2, and here we will consider the rate by 3, and the last one we consider R by 6. Okay, that is the bandwidth we are going to allocate for these applications. So the first like highest priority one, since the weight is 3, what we are doing is out of 60 megabit or megabyte bandwidth, we are going to allocate 30 megabytes for this one. Okay, because that has highest priority. Okay, next we are giving 20 bytes to the second one, 10 bytes to the third one. Okay, so the system processes the packets in each of these queue in round robin fashion, and how many number of packets we are selecting from each packet, it depends on the weight. Okay, if I have weights like 3 to 1, 3 packets are processed from first queue, 2 packets are processed from second queue, 1 packet is processed from third queue. In this way we are trying to have fairness. Okay, previously we had completely this one weighted like only priority we were considering, but now we are trying to have some kind of fairness to that by adding weight. Okay, so however this situation will be true if all three classes have same packet size. Okay, whatever I said, that will be easy to handle in case if I am going to have equal priority to all of these things. But in case if I don't have sorry, in case if I don't have equal size to all of these things, then we will be in trouble again. Okay, so these are scheduling things which we are doing at router. Clear all the three things?
Yes, sir.
Okay, so next we will be looking at traffic shaping. Okay, traffic shaping, we have uh, two techniques. Okay, traffic shaping is done to control the traffic when it leaves the network. Traffic policing is done before someone enters into the network. Okay, traffic policing or shaping, the difference is shaping is done one after you enter the network. Traffic policing is done before you enter the network. Okay. Okay, so we'll directly look with respect to this, you'll be able to understand. So I have, you can see lot of variations with respect to traffic here. When I go with policing, you are going to have a strict measure wherein we are going to discard things which are beyond the capacity. In traffic shaping, we are going to regulate the traffic. Okay, that is what we have. So first we will see leaky bucket algorithm. So leaky bucket algorithm you can consider like this. I have a bucket under which I made a hole. Okay, I have a bucket under which I made a hole. Okay, whether you increase or decrease the rate at which you are pouring water into the bucket, irrespective of that, the output will be constant. Yes or no?
Sir.
Okay. So, are we trying to regulate or not? Traffic which is coming out of the network. Okay. So leaky bucket, just remember one thing. Whatever may be the input, output I am going to do at a constant rate. Okay, so I had 12 Mbps for 2 seconds, that is total 24 megabytes of data, megabits of data, and for 3 seconds I had 2 Mbps, that is 6, total 30 Mbps. I just regulated that so that from 1 to 10 seconds I am sending a constant 3 Mbps. Okay, that is leaky bucket. So in leaky bucket, what happens? Whenever queue is full, discard the packet. Whenever queue is like space is there, you just add the things into queue. And whatever may be the speed at which you are coming, you are just doing like packets you are taking at constant rate. Okay. So this is something like whenever bucket is full, what happens? Water will come out, right? The same thing will happen here also. Okay. Token bucket. Basically what happens is, let us say in the case of leaky bucket, I don't have any water left over in the bucket. Whether you will be sending anything?
No, sir.
I won't be sending anything. But later, completely somebody has taken a bucket and poured complete bucket into this one. Then also I will be sending it the same rate. Okay. So basically in leaky bucket, the amount of time for which you are idle or not using, you are not considering. Okay. To overcome that, what we are doing in token bucket is we are also considering the amount of time for which you have not used the network. Okay, so see here, whenever the queue is full we are discarding, whenever it is having some space we are adding, and how you are doing is you are going to take one token from the bucket at a time. Okay, so in this case what happens is tokens we are trying to add at rate r per second, let us say. Okay, and tokens are discarded if bucket is full. One token we are trying to take at a time. So the bucket gets tokens at certain rate. Okay, let us say whether you are free or you are having some data, you are going to add, let us say, r tokens. 10 tokens you are adding for every 1 second. Okay, a token, what is the meaning of token is, this is the permission for source to send certain number of data units into the network. Okay, to send a packet we need to remove certain number of tokens. Okay, which equals in like we are going to consider like equal number of equal sizes for packets anyway. Okay, if you do not have enough number of packets, if not enough tokens are there in the bucket to send packet, then we will be doing like trying to queue the packets until the bucket has enough tokens, or you can also discard them. See, this is something like I have, I'll be adding, let us say 100 tokens for every 1 second. Okay, but I am trying to take 200 tokens out. Okay, whenever you are idle, what happens? These tokens get accumulated and we will be taking 200 tokens at a time. Okay, so if the bucket fills to specified capacity, newly arrived tokens are discarded, and a token bucket permits burstiness, but it tries to be in limit. Okay, we will try to, yeah, let me look into this particular example. Let us say bucket has a capacity of 10,000 tokens and tokens are added at 1000 tokens per second. Okay, if the system is idle for 10 seconds, the bucket collects how many? 10,000 tokens and it becomes completely full. Now, even though we are adding 10,000 tokens per second, we can do like 2000 tokens at a time we will be able to take out. Our maximum average rate we can calculate like this, 1000 into T, because we are calculating how many tokens are there in how many tokens are added per every unit time, and how many tokens are there, 10,000, 10 seconds we waited, right, divided by T. That will give what is the maximum average rate we can have. Okay, if T equals to 1, then I can have 11,000. If T equals to, let us say, 10, I can have 1100. Okay, that is the maximum average rate calculation. Okay, so clear. Whenever a token bucket algorithm we are implementing, we can have three policies: confirm access, configure to transmit the packet; exceed action, configure to transmit packet but with low priority; optional violate. In this case, we are going to drop the packet. Any of the three actions token bucket can do. So overall, when we consider token bucket and leaky bucket, this is something like in leaky bucket, we are generating, we are trying to send at same rate. Okay, but whenever you are idle, that credit you are not taking. In token bucket, the idle stage, we are going to accumulate tokens, right? That can be useful in next cases. Okay, so that is about leaky bucket and token bucket, and how we are handling